Welcome to Notes 5.8. Congratulations, you've made it through semester 1. This is our last notes for semester 1, so yay. Okay, we're going to be talking about polynomials in the real world. We will be using a calculator for this lesson. If you guys have a TI-84, it'd be a great time to take it out. If you downloaded the TI-84 free trial, take that out. And I'm actually going to be using an app on this one. So I'm going to be using, if you guys look at the bottom of my screen here, this calculator little app. It's not exactly like a TI-84, but it's similar enough that we will be able to go through on that one. So if you guys want to take the time, this was $5 to download to have all the capabilities that it has. I do recommend using the $5 so we can use all the stuff. All right, so we're going to talk about the n+1 principle. So the n+1 principle just says that your degree, which is going to be n, plus 1 is the number of points you need to make a unique graph containing that. So, for example, 2 points can be fitted into a line, 3 points can be fitted into a parabola, and 4 points can be fitted into a cubic function. Okay, so again, the degrees on all of these would be 1, 2, and 3. So if we have one more point than the degree, then we can make a unique function out of those points. Okay, so looking at the little graph, if we have 2 points, makes a linear, y equals ax plus b. 3 points, quadratic, y equals ax squared plus bx plus c. And if I had 4 points, we can make a cubic, y equals ax cubed plus bx squared plus cx plus d. Okay, so that's all that's saying. Okay, so this is the property of finite differences. I'm not going to read it to you because it's just kind of confusing. So what it is, or what it means is, if your x values are an equal distance or a consistent distance away from each other, so they're all going up by 1, they're all going up by 2, they're all going up by 3, you can find the differences between the y values, and if the first difference is the same, then it's a linear equation. If the second difference is the same, then it's a quadratic. If the third is the same, then it's a cubic, so on and so forth. So we can figure out, based off of the differences of the y values, what kind of function it is. So we're going to go ahead and look at this example 1. So first, make sure your x's are going up by a constant number. So 1, 2, 3, 4, that's good. They're all going up by 1. So now we're going to look at our y values, and we're going to find the differences between the y values. So the difference between 1 and 3 is 2. So I just do 3 minus 1 is 2. 6 minus 3 is 3. 10 minus 6 is 4. Okay, so this would be your guys' first differences. We want to do this until we find this number, these numbers are all the same number. Once they are the same number, then we know what kind of function we have. So 2, 3, and 4, not the same number. So we're going to do the differences between 2, 3, and 4. So the difference between 2 and 3 is 1. The difference between 3 and 4 is 1. Since they are both 1, so this is my second differences. And since the second differences are the same, 1 and 1, then I know that this is a quadratic function based off of those differences. Okay, you do need more than, so let's say these had not worked. If I had done one more row, I don't have enough numbers for that. So we would need, obviously, more points for the bigger equations. All right, so we're going to go ahead to the next page. So we're going to use this difference of constants, and we're going to find the what kind of function this is. So same as what we did on the last problem. So first thing you want to check is your x values. Are they going up by a constant number? 3, 6, 9, 12, 15. Yes, they're all going up by 3. It is constant. We're good. So now we're going to look at the differences of our y values. So 31 and 16, so I do 31 minus 16 is 15. 46 minus 31, 15. 61 minus 46, 15. 76 minus 61, 15. Okay, so this is my first differences. And they are all the same, 15, 15, 15, 15. So since they are all the same, I automatically know that I have a linear equation. All right, so a linear equation is y equals mx plus b. So we want to find this equation that fits this data set. Okay, so let's go ahead and figure out what is our slope. So remember to find slope given 2 points. We're going to do y2 minus y1 divided by x2 minus x1. This will help us find our slope. So we're going to do 6 minus 3. So I'm doing the first 2 points here. I'm using this point set and this point set. So we'll have 6 minus 3 and then 31 minus 16. So we're going to get 3. Oh, I did that backwards. Hold up. I did my x's instead of my y's on top. Reverse. Okay, y's are on top. So we're going to do 31 minus 16 over 6 minus 3. There we go. So we get 15 over 3, and 15 over 3 gives me 5. So my slope for this guy is 5. Okay, then remember the b portion here. This is your y-intercept. Okay, so we can find a y-intercept when x is 0. So if I go here, these are still evenly distanced apart. 0, 3, 6, 9, 12, 15. So then we know the differences between the y is 15. So we're going to do 16 minus 15, which is 1. So my b value is 1. Okay, so now we can make our formula. So y equals m, which is 5, x plus b, which is 1. So the equation that would satisfy this data would be y equals 5x plus 1. All right, we're going to skip the next one, go to the next page. Notice at the top of this page, I've already told you guys how to turn on your diagnostics. On the app that I'm using, the diagnostics is already on, okay? But if you actually have a TI-84 or you're using the TI-84 download, you guys need to go ahead, turn on that diagnostics. Maybe before we turn on this diagnostics, let's review how to reset the memory. So remember to reset your memory. I definitely spelled that wrong. This is why I don't teach English. And there we go. So to reset our memory, we hit second, the plus sign, and then you'll hit 7, then number 1, and then number 2. 712. And then it will reset that RAM. I'll show you guys how to do it on this little calculator. So on this downloaded app, we're going to have to turn our screen. There we go. We'll go second plus sign memory. This one doesn't have 7. We're just going to go reset all RAM. And then you want to press enter. And now it's all reset. So we're good. Okay, perfect. Let's go back. Okay, so it says the table below represents the population of a new community over a 5-year period of time. So here it is. And then remember the whole reason we turned on that diagnostics, that's what's going to give us our correlation coefficient, or that's what's going to tell us how strong is the regression that fits the data. So we're going to go ahead. We need to go type this into our calculators. The directions I'm going to give you is for the TI-84, not for the app. The app is similar enough that you guys will be able to figure it out, but I really want you to know how to do the actual calculator. So if we go here, so the first thing we want to do is we want to type in this data. So I'm going to write the directions right here. So you're going to hit the button that says Stat, and then you're going to go to the part that says Edit, and then we're going to edit, or I'll do this. We're going to edit list 1 and list 2. So in list 1, we'll do 1, 2, 3, 4, 5. In list 2, we'll do that population numbers. Okay, so I'm going to go ahead and do this on my little calculator. So on this calculator, we're going to go Stat. We're going to go to Edit, and then we're going to go to list 1. So type in our numbers in list 1. And then we're going to move ourselves over to list 2, put in those numbers. 535. Okay, and then just double check your guys' list just to make sure that they are correct. So I'm just double checking mine. If you have one number off, you're going to get the wrong answer, and we wouldn't want that to happen. Okay, so we go stat, edit. Okay, so then the next thing it says is make a scatter plot. So remember, to make a scatter plot, we're going to go to second, and then we're going to hit Y equals button, which really says, on top of it says stat plot. So we're going to stat plot. Okay, and then on the normal calculator, you go to number 1 and you turn it on. Okay, once it is on, to see the graph, you're going to hit the graph button. And then you're going to do zoom number 9, which is zoom stat, and then it will zoom in right on this picture that we're seeing on our page right here. All right, so that's what we're going to go ahead and do. We're going to do it on my app. So on our calculator app here, similar setup. So we're going to go second Y equals. You know what? Actually, let's make sure we go home first. Go second quit or second mode. And I did not hit second. Second quit. So now we're on our home screen. Now go there. So we're going to go second stat plot. We're going to turn our first one on. So if your guys's looks like mine, both of these would be off and off. So we're going to go X is list 1, list 2. We want a scatter plot. So now this guy is on. And then we're going to hit the graph button. Okay, mine's already zoomed in because I already found it. So, which is like really confusing to do. So you guys are going to zoom in to see that data. Remember, if we're actually on a TI-84, you guys will be able to just hit zoom 9 and it's going to do this process for us. So you're just going to find those data points and you're going to zoom way in. So notice we're going to have one on 1, 2, 3, 4, and 5. And then it's the Y that you really need to zoom in on. So if you guys look at my scale right now, you'll be able to tell. So kind of keep these looking the same-ish, whatever. Okay, so we're going to zoom all in so I can see my 5 points here. Okay, so now what we're trying to do is we're trying to find the proper regression to fit this data. So is this a linear regression, a quadratic regression, a cubic regression, a quartic regression? So that's what we need to calculate next. When we go ahead and calculate this, we're going to want to record it to find the best one. So you're going to have to try all of them out, and we're looking for the closest R squared value to 1. The closer it is to 1, the more perfect it is. If it is 1, that means it is perfect, and there is points that go through this. So let's go ahead and go back to our notes. All right, and I'm going to remind you guys how to calculate these regressions. Okay, so to calculate a regression on our calculator here, we're going to go to stat. So we'll go to stat. Now you're going to go over to calculate. And then we go to regression. So you're going to pick whichever regression. So if we're going to pick a linear regression, you'll pick linear regression. Quadratic, we're going to check them all. And then we're going to go to store equation. And remember, to store the equation, you hit alpha F4, which is on the trace button on the normal calculator. And then you'll choose Y1. So we're going to store it in Y1. And then you hit calculate. So again, these are directions, and please write down these directions for the actual TI-84. My app, It's going to be a little bit different, but still very similar. Okay, so what we want to do is we want to run all the different regressions. So we're going to run a linear regression, a quadratic regression, a cubic regression, a quartic regression. So we're going to run them all. And then we're going to write down what are the r squared values, and the r squared that is the closest to 1 is our best representation of this data. All right, so let's go ahead and do that. So on this app, we're just going to close out, go back to the home screen. So again, we go to Stat, and then we go over to Calculate. Okay, we're going to start with the linear regression. So ax plus b, so that's number 4. So we're going to go ahead and type that in. Our data is in list 1 and list 2. So if you guys hit the second button, it'll give you, if you hit second 1, second 2, it gives you L1 and L2. So L1, second L2. We want to store our regression. So again, we're going to go alpha. And then when you guys hit alpha on this little app thing, then you go to F4, Y variance. And then we choose, so if you guys see that, we're right here, and we choose Y1. All right, from here, we're going to go ahead and click Calculate. And there it is, and we're going to write down those r squared numbers. So this r squared is 0.88935. So now we're going to go ahead and write that down. So we have, for this first one, 0.88935. All right, now we're going to do that same process, and then we're going to do it for a quadratic. So for the quadratic now. So we'll go back. We'll go to Stat, Calculate. Now we're going to do quadratic. So on this one, it's number 5. And why didn't it go anywhere? Maybe I didn't have to clear this. Let's try that again. I had to push enter on that last one, I think. So now we're going to go Stat, quadratic regression. Again, we're going to do L1 and L2. We're going to store it in the same... I guess right now we technically don't need to store them. We need to store it once we figure out which one's the best one. So we'll just calculate for now. Don't need to store. Okay, so this r squared is closer. It's 0.99557. So which is good. So we're going to go 0.99557. So we're getting closer to 1. So the quadratic is better than the linear. Keep going though. So now we're going to do this again. Clear it out. So we'll go Stat. Now we're going to do a cubic regression. Same process. L1, L2. Calculate that one. This r squared is even closer, 0.99942. So let's write that down. So for the cubic, we're at 0.999942. So far the cubic is the best model, but let's run that quartic one. So we'll go ahead, enter, clear. So now we're going to run a quartic regression, same process, L1, L2. And let's go ahead. I already ran this one, that's why it's already in here. So let me clear that, and we're going to calculate. Okay, this r squared is 1. If it has a value of 1, that means it's perfect. It goes through all of those points. So it's the best model by far. So the best model for this particular question is a quartic. Okay, so the quartic model is the best. We're going to write down that equation of that quartic model. In my class, we round 3 decimal places, so that's what we're going to round all these values. Okay, so if I go back to looking at my calculator, it gives you the formula. So it says y equals ax to the 4th plus bx cubed plus cx squared plus dx plus e, and then it gives us all the values, the a value, the b value, the c value, the d value, the e value. So we're just going to plug that into the equation and write that equation out. So we would get y equals 13.042 x to the 4th power minus 70.75 x cubed plus 303.458 x squared. Man, I'm going to run out of room. And then we're going to get, let's zoom in here so I can make more room, minus 142.75x plus 4,321. I think that was correct. Let's double check. Oh, 432. Eraser, little one. All right, so this is the equation of the best fit model for this data. Okay, in the beginning I told you guys that n plus 1 is in order to make a perfect one. So notice I have 5 points, okay? So 5 minus 1 is 4, so that means a quartic would fit this perfectly if I had 5 points. So we could have known from the beginning, just knowing that, the quartic was going to be the best option here. But this is the process to doing it. Just in case we had like 20 data points, this would be the process to finding what would fit the data the best. All right, so we're going to go ahead and just do one more. We're going to go to the next page. We're going to do example 6. Okay, so it says find a quartic model and a cubic model. Which one's the best one? And then we're going to find a value. All right, and we'll see how finding a value goes on this app because I'm not sure how it will go. Okay, so we just want to find a quartic and a cubic. So we want to figure out what is the, let's actually erase that. What is the r squared value for a quartic, or for a cubic, and for a quartic? Okay, once we find it, then we'll go ahead and find the model. So, back to the calculator. Okay, now we need to go to our stats. We need to go to edit, and we're going to have to clear out these lists. So, let's see if I hit clear. So if you guys like highlight the lists and push clear, it'll clear them out. Go back to list 1. And then we can start typing in our new ones. So we have 0, 3, 6, 10, 14, 18, 21. Okay, go to our list 2. And we have 17, 4, 22, 17, 4, 22, 17, 4, 22, 45, 90, 78, 42. Again, we want to go ahead, double check these, make sure that we have all of these points in here correctly so we don't make just like silly little mistakes. All right, cool. Okay, so now we're going to start running those regressions. So when we start running those regressions, we're going to go, let's quit out of here. So second mode or second home. Let's clear this home page. So we're going to go to stat, we're going to go to calculate, and we're going to start with the cubic. Again, we're in list 1, we're in list 2, so type those in. We're going to calculate. Right now we just want that r squared value. So 0.97755. That's what we'll write. You want a lot of decimals because some of these will be really close and similar to each other. So for this, we're going to have, what did I just say? 7.97757. Okay, so that's for the cubic. Now we're going to run it for the quartic. Okay, so running it for the quartic, we're going to go ahead and do stat quartic regression. Again, we want list 1, list 2, calculate. This r squared is 0.9778, so that one is a little bit stronger. So we have 0.97778. Okay, so that's going to be our stronger model. So now we want to write down what is that model. So y equals, so we're going to take all those values that it gives us, and we're going to plug those in. And A seems really, really tiny. Yeah, A is super tiny. Did I make a mistake? Hopefully not. Okay, so we need to write that down. So we'll go 0.00358. It's just going to be big. So y equals negative 0.00358 x to the 4th minus 0.058 x cubed plus 1.85x squared minus 8.83x plus 16.9. Let me double check that. Perfect. Okay, so that's our regression. We want to go ahead and store that regression because we haven't stored it yet. So we're just going to recalculate it. So we're going to go to stat, quartic, list 1, list 2. We want to store this regression. So again, we're going to hit alpha F4, choose Y1. Push calculate. And now it has stored our regression. Okay, so this should all be stored. It should be in our graph, so we're going to hit graph. We're obviously going to have to zoom differently now. So I see some of my stuff down here. And this is such a pain. Remember, if you guys have the actual calculator, you guys won't have to do this so terribly. There we go. So just zoom until you guys get it to kind of look like this. Okay, so this is what our graph would look like. We need to calculate, it says use your model to find the number of vehicles that pass through the intersection at 5 p.m. daily. 5 p.m. is really 1700 hours. We need to use military time. So on this app, we're going to just go to calculate, and I'm going to assume for the x value, we're going to type in 17. I hope this works. And press enter. Yes, it does. Thank goodness. Okay, so the y value at 17 is 86.8. Okay, we're going to obviously round this up. We have whole cars. We need a whole car. So about 87 cars go through that intersection at 5 p.m. So let's go ahead and write that in. Okay, so which model was the best? We already said the quartic. model because r squared is closest to 1. Okay, use that model to find it. So again, remember 5 p.m. is really 1700 hours. So 87 cars was our answer. And then let's just write down the directions on how to do that on the actual TI-84. On the actual TI-84, you guys would have gone to the graph. And then you would have pressed trace. And then you would have hit value. And I actually forgot a second, or it should be second trace button. So you would hit second trace, which is really calculate, and then go to value. All right, thanks for bearing with me with this craziness with using an app instead of the actual TI-84. Wanted to try something else out. So again, that app was only $5. It's a pretty good one compared to the TI-84. If you guys want to buy that, I do recommend it. All right, congrats on finishing semester 1. Have a great day, guys.